Okay, so let's take a look at the questions that you had from the last day. On page 638, number 1, calculate the electrostatic force between charges of negative 2.4 and microcoulombs and positive 5.3 microcoulombs placed 58 centimeters apart in a vacuum. So, just take your equation, FQ is equal to KQ1 Q2 over R squared. Fill your numbers in. 9 times 10 to the 9th Newton meters squared per coulomb squared. The first charge they gave us was negative 2.4 microcoulombs. So negative 2.4 times 10 to the 6th coulombs. Second charge was 5.3 microcoulombs times 10 to the 6th again. And then divide it, and it says they're 58 centimeters apart. You have to change that to meters, so 0.58 meters, and don't forget to square it. And when you do this, you get an FQ of 0.340 newtons, but it's negative, and the negative means it's repelling. Okay? No, it doesn't. Negative means attracting. Negative. Attracting force is a negative thing. Attraction. Sorry about that. All right. Number 2. I was reading the next question in case you're wondering why I got that mixed up, because I was thinking about something else. The electrostatic force of attraction between charges of positive 4 microcoulombs and negative 3 microcoulombs is 1.7 times 10 to the negative 1 newtons. What is the distance between them? So FQ is equal to KQ1 Q2 over R squared, but this time you're solving for R, so you need to rearrange FQ KQQ over FQ. So 9 times 10 to the 9th Newton meters squared per coulomb squared tells us our charges are 4 microcoulombs, so 4 times 10 to the negative 6, and negative 3 microcoulombs, negative 3 times 10 to the negative 6. And it says it's a force of attraction of 1.7 times 10 to the negative 1 newtons. A force of attraction. You have to put a negative in here. Now, if you screwed up and didn't put a negative in there, you would get a negative for your R squared, and then you'd be like, wait, I can't take a negative of my R squared, and then you do what all good physics students would do. You just ignore the negative and take the square root anyway. But really, the FQ goes in as a negative, and then your R squared ends up being a positive 0.6353. And that's meters squared. Then you take the square root and you get 0.7, if only I could see, 777, I believe. Couldn't tell if it was 3 sevens or if one was a 9. Okay? So watch the negative on your attractive force, and that's why I screwed it up the last time. Number 3. 2 identically charged objects exert a force on each other of 2 times 10 to the negative 2 newtons. When they are placed 34 centimeters apart, what is the magnitude of the charge on each object? So FQ is equal to KQQ over R squared. They're saying identically charged, so you could write this as KQ squared over R squared. And it's the Q squared that we're looking for. Well, really the Q, but so it'll be R squared times FQ over K when you rearrange. So it told us they were placed 34 centimeters apart, so 0.34 meters squared. It said the FQ was 2 times 10 to the negative 2. And if they're identically charged, they're going to repel, and so it should be a positive. You don't have to worry about your negative here. And this will be K is 9 times 10 to the 9th Newton meters squared per coulomb squared. And you will get a Q squared to be 5, oh no, that's Q, 2.5689 times 10 to the negative 13, I believe. Coulombs squared, take the square root, and you get Q to be 5.068 times 10 to the negative 7 coulombs. Asked for magnitude in the question, meaning just how big it is. It didn't ask for nature. If they're identical charges, then it would be either both must be positive or both negative. Remember, when you take the square root, you get a plus and a minus, right? So here, though, it can't be like one's plus and one's minus because they wouldn't be identical then and they wouldn't be repelling. So either they both have to be positive or they both have to be negative. I'm saying that because there's another question at some point you'll probably see when it asks for the nature, and that's what it's looking for. All right, number 4. Two oppositely charged objects exert a force of attraction of 8 newtons on each other. So FQ, force of attraction, negative thing. What will be the new force of attraction if the objects are moved to a distance 4 times their original? So you don't actually have to do any math here. Just look at the equation. So right now, that's equal to negative 8. But if I make R bigger, FQ is going to get smaller. And so it says I'm going to move them a distance of 4 times. So if I make R 4 times bigger, and that gets squared, which would be 16, then FQ should be 16 times smaller. And so it should be negative 8 over 16, or negative 1/2 a Newton. Okay? Now you could have, they're oppositely charged, but we're assuming the same magnitude. So you could have tried to solve for it here, like you could have made up numbers or something. But really, like if I double R, then FQ is going to be 1/4 as big, right? Because it gets squared. So this is called an inverse square law. So whatever happens to one, the other changes in the opposite direction by a square of that factor. Okay? All right, number 5 says, two identically charged objects have charges of 6 microcoulombs, Q1, 6 microcoulombs, and negative 2 microcoulombs when they are placed some distance d apart. So R is equal to d. Their force of attraction is 2 newtons, so FQ is 2 newtons. So we can find what D is, right? FQ is equal to KQQ over R squared. So R squared is equal to, KQQ over FQ. So R squared is equal to 9 times 10 to the 9th Newton meter squared per Coulomb squared times 6 to the negative 6 negative 2 to the negative 6 coulombs divided by 2 newtons, and it must be a force of attraction because I put a negative on there. Yeah. And so you do this and get your R, and so when you do this to get your R, you should get, trying to figure out which one, 0.4648 meters. But the question doesn't end there. The question then says, if the objects are touched together, now if they're touched together, remember when they're touched together, they're going to share their electrons, and you can find the new Q's by adding them and dividing by 2. So add 6 and negative 2 and divide by 2 and get 2 microcoulombs each. I'm going to run out of time if I don't hurry here. And then it says their distance of separation is 2d, so R is now going to be 2 times the old R. What's the new force? So QQ over R squared. So 9 to the 9th. Hurry, 2 microcoulombs squared, you have to put in the negative 6, and then 2 times 0.4648, and all of this gets squared. And when you do this, you should get an FQ of 0.16